Hello and welcome back to the Cracking Fan YouTube channel. Today we're solving the daily Leetcode problem 884, uncommon words from two sentences. A sentence is a string of single-spaced separated words where each word consists of only lowercase letters. A word is uncommon if it appears exactly once in one of the sentences and does not appear in the other sentence. Given two sentences, S1 and S2, return a list of all the uncommon words. You can return the list in any order. Let's look at a very basic example. This apple is sweet and this apple is sour. We can see that this apple occurs in both words, occurs in both words, and the only two that are different are sweet and sour, which both occur once, and there you go. We have sweet and sour. So this problem, relatively straightforward. All we really need to do here is get the count of each of the words in all of the sentences, and then basically go through all of those counts for each word. And if a word only appears once, then we know it's an uncommon word, because there, by definition, it only appears in one of the sentences and does not appear in the other because it only has a count of one. Therefore, it's an uncommon word. So all we want to do is just have a dictionary. We'll go through both of the words, get each of the words from it. Each of the sentences, get each of the words, put them in the dictionary. Then we just need to get all of the dictionary values, keys whose value is 1. And that's really all we have to do. Relatively straightforward, quite an easy problem. So let's code this one up. We're gonna need, like I said, a dictionary to store the counts of all the words that we encounter in string 1 and string 2. So let's define that. We're gonna say counts_dict. It's gonna equal to collections.defaultDict int. So, okay, now we just need to go through S1 and S2 to basically get all of the words. So we're going to say for word in s1.split, because remember it's given to us as a string. We need to split it so we can actually get the white space out. So we're going to say, so for each word, we're just going to say counts_dict of that word, and we're going to increment its count by 1. And we're going to do the same thing for the second string. So we're going to say for word in s2.split, we're going to say counts_dict of word plus equals to 1. Now all we need to do is just return the keys in our counts_dict where the count is actually equal to 1, because that means that it only occurs once, which is by definition our uncommon word. So we're simply going to return, and we can use a list comprehension here because we're using Python. So we're going to return all the words for a word in counts_dict if the counts_dict for that word, counts_dict equals to 1. So for all of the words in our counts_dict, basically for all the keys, if the value at that key equals to 1, then we want to return the word. And basically that will give us our solution. So let's just run this, make sure it's good, submit it, and we are good to go. So before we go, quick time and space complexity. Obviously we need to go over all of the words in S1 and S2. And basically this will be big O of n plus m, where n equals the length of S1 and m equals the length of S2. So basically, yeah, we need to just iterate over every single, we need to iterate over both of the strings to get each of the words. And then for the space complexity, same thing. We need to store all of these words. In the worst case, all of the strings are going to have unique words, so we're gonna have to store all of those. So it's going to be big O of n plus m as well. Okay, actually maybe this n equals the, it's probably num words in S1, I think. Yeah, I think it's maybe the words actually. Num words in S2. Okay, cool. Anyway, it's still just going to be linear. We need to parse through both of the strings. So what exactly n and m here is, I forget, but anyway. That's how you solve this problem. Hope you enjoyed it. Easy problem for the daily question. Subscribe to the channel for more daily videos, and I will see you in the next one. Bye.